All right, let's get right into it. One of the biggest challenges in AI today, probably the biggest, is teaching a robot how to do complex stuff in the real world. I'm not talking about just picking up a wooden block. I mean, how do you get it to understand and interact with our messy, unpredictable world in a way that's actually useful? Well, today we're going to look at a pretty groundbreaking platform that might just be the key to unlocking all of that. This quote from the legendary computer scientist Alan Kay, it just hits the nail on the head for what we're talking about. Because what if the secret to getting a robot to act correctly is to first teach it how to imagine, to literally invent a plausible future for itself, frame by frame, before it even moves a single motor? And yeah, that is the multi-billion-dollar question, isn't it? It sounds like something straight out of science fiction. But it's the very problem that this new platform called Genie Envisioner is built to solve. It's all about giving a robot something that looks a lot like a human imagination.
Okay, so before we jump into the amazing solution, we really need to understand why the problem has been such a nightmare to solve. Until now, training a truly capable robot has been, frankly, a total mess. A slow, clunky, and incredibly difficult process.
So here's the core of it. The old way is this clumsy patchwork. You've got all these different, separate stages for collecting data, for training the AI, for testing it out, and each one needs its own special, custom-built system. It makes everything painfully slow, and when something goes wrong, good luck figuring out where the failure happened. The Genie way just flips that whole table over. It puts everything into one single unified platform that learns directly from watching videos. And that makes trying new things, iterating, incredibly fast.
So how in the world does Genie pull off this unified approach? This is where we get to the real magic trick, the breakthrough idea that gives a robot its imagination.
Okay, so the official term is a Unified World Foundation Platform. I know, that's a mouthful. But what it really means is that it takes everything, learning what to do, practicing how to do it, and checking its own work, and smashes it all into one system. And the engine driving the whole thing? It's video generation. The robot learns how the world works by watching, and then it imagines the video of what it needs to do next.
And the reason it's so powerful is where it gets its knowledge. A massive, and I mean massive, amount of real-world data. The main model was trained on over 1 million video clips of actual robots doing actual tasks. That's over 3,000 hours of footage. So it isn't learning in some perfect, sterile simulation. It's learning from the messy, chaotic, unpredictable physics of reality itself.
So how does this imagination really work day to day for the robot?
Well, it's best to think of it as a simple 3-part loop. Dream, act, and simulate.
It all kicks off with G-Base, which you can think of as the dreamer. It's the part that binged all those thousands of hours of video to just understand how things move and interact. When you give it a command, it dreams up a little video of what a successful outcome looks like. Then, it passes that dream to G-Act, the doer. This part is the pragmatist. It translates that fuzzy video plan into precise, concrete motor commands for the robot. And finally, to get really good, it uses G-Sim, which is basically the practice room. It's a virtual world where it can try out its plan thousands of times an hour, learning and getting better way faster than it ever could in the real world.
Okay, so that all sounds incredible on paper. But, talk is cheap. Does it actually work? The researchers really put Genie through the ringer, testing it against other top-tier systems. And honestly, the results are kind of mind-blowing.
Just look at this. They tested it on a really, really hard task. Folding clothes. I mean, even humans hate that. And the results are just staggering. G-Act nails it with a 76% success rate. The next best competitor, P0, only gets to 48%. And look at the other two leading models, Univila and GROOT. They scored a big fat 0. They completely failed. This isn't just a little bit better, this is a whole different league.
But here's the real kicker. The true power of Genie isn't just that it can do one task really well on one specific robot. It's about generalization. It can take what it's learned and apply it to totally new robot bodies it's never seen before, like the Agilix Cobot or a pair of Franca arms. It's especially good at those super tricky tasks with things like cloth or cardboard boxes. And the craziest part? It figures all this out with a shockingly tiny amount of new data.
This number right here is the one that really matters.
To learn a brand new task on a robot it's never used before, GE needs just 1 single hour of new demonstration data. That's it. That kind of efficiency is what could finally make general-purpose robotics scalable. We're talking about moving beyond needing months or even years of training for every single new thing we want a robot to do.
So let's just zoom out for a second. What does a technology like this actually mean for the future? This is way more than just a cool lab experiment. This could signal a fundamental shift in how we build and use robots, period. So, the big takeaway is this. Genie Envisioner gives us a blueprint, a kind of recipe for creating robots that are genuinely general purpose. We're finally starting to move away from the idea of a robot that's stuck doing one single repetitive task on a factory floor, and we're moving toward robots that can actually learn and adapt to our homes, our offices, our world.
And this whole thing leaves us with a really provocative thought. We're on the cusp of a world where teaching a robot a new physical skill might be as easy as just showing it a video. So the question is changing from can we do this to what should we do with it? If you could teach a robot to do absolutely anything just by showing it, what would you teach it first?